So today, very short, brief video. We have a topic in chemical kinetics, that is the collision theory. So in collision theory, what we study for a chemical reaction, collision occurs among the molecules. Among the molecules. So the frequency of collision is very high. So in case of binary solution, in case of binary collision, the frequency is about 10 to the power 25 to 10 to the power 28. So for every chemical reaction, a collision occurs among the molecule. So in case if you take the example of binary collision, the frequency is so high that you can see here that is a 10 to the power 25 to 10 to the power 28. And in case of chemical reaction, whenever a collision occurs, so every collision does not bring products. So whenever reactants react with each other, so when a collision occurs between the reactants molecule, so every collision does not bring about the products. So that is called as the ineffective collision. Ineffective collision. And when the collision occurs among the reactant molecule and it forms a product, that is called as the effective collision. So when collision occurs and it forms products, that is the effective collision. So in this video, now we will study on what factor does the effective collision depends upon. So we will study for an effective collision. For an effective collision, two things depends. That is, first one is the energy barrier, and second one is the orientation factor. So in any energy barrier, what we are studying, in energy barrier, every molecule must possess a minimum energy that is required for the participation in a chemical reaction, that is called as the threshold energy. So in energy barrier, two things we need to understand. First one is the threshold energy. Threshold energy. So what is threshold energy? So this is the minimum amount of energy that is required for the participation in a chemical reaction. So it is the minimum amount of energy, minimum amount of energy required for the participation in a chemical reaction. So this is the threshold energy. And the second one, that is the activation energy. additional amount of energy required to attain the threshold energy, to attain the threshold energy. Threshold energy we can understand through a graph also. For example, if you take a graph, so for example we have a graph here. So here the reactant, for example, A plus B, that is a reactant, and this is the reactant reacting with each other. So and to for a reaction to happen, this is the threshold energy. This is the minimum amount of energy that molecule A and B must possess to attain this threshold energy. So this is the threshold energy, and this energy is the molecule that initially that it possesses, it is the average kinetic energy. So this is the average kinetic energy of molecules, and this is the threshold energy. This is the minimum amount of energy that is required for the reactant A and B to form a product, that is C and D. So this is the product and this is the reactant. So a reactant must possess that is the minimum threshold energy to form a product C and D. So and what this is the average kinetic energy of the molecule that it has, and it is the this one is the additional amount of energy. This is the additional amount of energy that we are giving the molecule to attain the threshold energy, that is the activation energy. This is the activation energy, and this activation energy is represented by pH and threshold energy is represented by pH. So you can understand that through the graph, for a reactant to form a product C or D, this pH is the minimum amount of energy that is required for the participation in a chemical reaction, and this energy that the molecule A and B possess here, and this energy from here to for example this is the M and this is the N. So M and this x-axis represent the additional amount of energy that is required to attain the threshold energy. So we can say here that threshold energy is equal to average kinetic energy of molecules plus E, that is the activation energy.